In this video, we will be discussing the condenser fan and motor, a possible cause of high head pressure. Let's look at the issues with the condenser fan. Usually, if you discover high head pressure, you would look at the cleanliness of the condenser coil, and in most cases, you would probably be correct. The thing that is sometimes overlooked is the condenser fan. Defective motor, defective capacitor, defective fan blade, or misaligned fan blade. In this video, I will discuss these four components of the condenser fan. After you have determined that the condenser coil is clean, the fan motor, capacitor, and blade must be assessed. The voltage should be checked to be sure it is within 10% of the nameplate specifications. To drive the fan, which is connected to the motor shaft, and the voltage is low, the motor characteristics will change. The motor requires a certain amount of power, that's volts times amps. When the voltage is low, the amps will increase to provide the necessary power. When the amps exceed the nameplate rating, the motor will heat up, damaging the windings. High voltage on a motor pushes the magnetic portion of the motor towards its saturation, causing the motor to draw excessive current. An amp draw on the motor should be taken to determine if it was within the motor nameplate rating. The resistance of a PSC motor should be checked in order to determine if the windings are defective. Manufacturers of PSC motors connect the motor leads either with 3 or 4 leads. On a 4-wire motor, one brown wire is the start winding, the other brown wire is attached to the run winding. Below are depictions of the internal wiring and external wiring of each motor. What happens if a capacitor fails on a permanent split capacitor motor? A failed capacitor will cause the PSC motor to either stop or run more slowly than designed, and the thermal protector may trip when a restart is attempted. The capacitance of a capacitor can be checked with no motor connected or under load. With a capacitor discharged, it can be checked with the capacitance setting on a modern multimeter. It must check within the variance on the capacitor, usually between 5 and 10%. To test the capacitor under load, we first measure the amperage of just the start wire. Next, we measure the voltage between the two capacitor terminals. The formula is microfarads is equal to start winding amps times 2,652, which is a constant, divided by the capacitor voltage. In our example, we have shown 1 amp draw and 271 volts. Therefore, the microfarads is equal to 1 times 2,652 divided by 271. Therefore, microfarads is equal to 9.78. The capacitor is a 10 microfarad capacitor and is running under load at 9.78 microfarads, which is within specifications. When replacing a motor, the following must be considered. Horsepower. The PSC motor is a constant torque motor and the equipment manufacturer designed for specific horsepower. RPM. The RPM and the fan blade work as a unit along with the motor. Voltage. The voltage should match the system voltage. Capacitor. The capacitor should be changed and be the one the nameplate of the new motor identifies. Shaft size. Unless you are changing the fan blade, you need the same shaft size. Remember that universal multi-speed motors go down in horsepower as the speed is reduced and may require a different capacitor. The ECM 142 is a 1/3 horsepower single-speed motor. The ECM 142R is a 1/3 horsepower and a 1/5 horsepower two-stage motor. The ECM 142 or the 142R condenser motors have 208 230 volts wired to the motor continuously. The motor is turned on and off by a 24-volt signal from the control board. The following method should be used to diagnose an ECM condenser motor. Check to see you have 208 230 voltage at the motor. If you do not have the proper voltage, check the unit wiring. If the voltage is present at the motor, check the 24 volts at the motor. If you do not have 24 volts at the motor, check the unit controls. If you have both line and low voltage and the motor does not run, the motor is defective. The blade and shroud are designed to match the middle center of the blade with the bottom of the fan shroud. The dotted lines in the pictures below show the blade position. Two issues can occur when the fan blade is below the shroud. Higher than normal high side pressure due to recirculation of warm air back through the condenser. Noise due to the vibration of the shroud. Two issues can occur when the fan blade is too high in the shroud. Higher than normal high side pressure due to restricted CFMs. That's air pulling through the smaller shroud opening. Lower efficiency on the entire system. Fan blades are not universal. The following must be considered: diameter, number of blades, pitch of the blades, size of the blades, rotation of the blade, and the bore. An incorrect fan blade can either move too much or too little air across the condenser and may cause higher than normal head pressure, low or high subcooling. Join me on Facebook at Certified HVAC Training to view other training material.